Hello friends, welcome to today's class. This is your Professor Vinay Sangoli here. So going ahead from the previous classes, whatever we have covered, today we'll move ahead for the next topic. So we have started with your classes and objects, that is module number 4 and chapter number 15. In the previous class we have seen regarding your attributes and how to create a class, how to create an object, how to fetch the attributes, and all those things has been done in your previous class. To move ahead from that previous discussion, today we'll move ahead for the example. The example we have taken here is of the rectangles. That is, we would like to create a class to represent rectangles. That means we should decide what attributes have to be chosen and where I have to store this rectangle and what size it must be. So all these three parameters has to be kept into our mind, and we should also try to make it bit simple by what we'll do is we'll not consider the angle. We'll only consider your width, height and the corner. So that means we'll try to reduce some complexities so that the class or the object which we are creating would be much simpler. Okay, so friends, we'll try to create an object rectangle. That is, this rectangle will be having the attributes width, height and corner. Okay, so the diagram which you can see right now is nothing but the definition of the rectangle object. Okay, and this rectangle object will be falling under one of the classes. Say the class name is geometrical objects. Okay, so now moving ahead, whatever we will try to do here is we will try to take into consideration two possibilities. One is we can specify the corner of a rectangle, the width and height. This is our first possibility. The second possibility is we should specify two opposing corners. That is, we will try to specify two opposing corners so that the whole rectangle could be plotted out. Okay, so that is what this the first diagram is telling you. It is an object called as rectangle which has three attributes: width, height and corner, and this will in turn point to two values which are nothing but your x and y. So x and y are nothing but your opposing corners. Okay, so as just now we have decided that we will be giving two opposing corners. Okay, now as you can see in the second thing here we are trying to assign the values to your attributes. So the first statement, box is equal to rectangle, is nothing but we are creating an object called as rectangle. Okay, and so later what will happen is once the rectangle has been created, we'll try to instantiate it and assign values to the attributes. So once the object has been created, the next very important thing is it has to be instantiated. So that's what we'll be doing. After that, you can see here the dot operator. The dot operator is nothing but you are assigning the attributes. Like say for example, if the expression box dot corner dot y, say box dot corner dot y, it means that go to the object box, refer to and select the attribute name corner, then go to the selected attributed name y. I hope this is clear. First you go to box, from box you go to corner, from corner you go to y. This could be represented with the help of this diagram. That is, first from box, then from the box to the attribute corner, from the corner to the value y. And what is the value of y? It is 0.0. Okay, so this is how you go on mentioning your objects. The objects which we can see in this above figure is called as an embedded object, as it has an attribute of another object within an object. That is, first you have an object, then you have an attribute, then for that attribute there is one more object. So this is called as object within a object, or the best name is, or the actual name, the proper name is embedded. It is called as embedded. Okay, so moving ahead friends, the next thing we'll be seeing is how to return the values. That is how your values could be returned from the objects. So in order to return, the first method or the method we will be using here is with the help of the functions. We will be using the functions to return the values or to return the instances. So here we have defined a function called as find underscore center, which takes a rectangle as an attribute and returns a point that contains the coordinates of the center of the rectangle. You can see it here, it is returning P. P is nothing but what now? It is pointing to a point. So you can see here return P. But what is P? P is nothing but the point. And what this P contains? It contains the coordinates of the center of the rectangle. You can see these are my coordinates, that is X and Y. Right. So once this has been done, once the box has been taken as argument, and what we'll do, we'll assign the points to the center. So this is how you call your function. So you can see here in this example, we are passing box as an argument and assigns the resulting point to the center. So you can see whatever the result we have got, that has been assigned to the center, and its answer is what now? 50, 100. So I hope this is clear. So what all did we do then? We have created a object. Yes, we have created an object here, or we can say object within the object, embedded object. Then we have returned the values from the object. How we have returned the values? With the help of the functions. Okay, so this is one part. Moving ahead, the next very important thing we are seeing is our objects are mutable. So I hope you have already heard this word mutable. You might have seen some of our things are non-mutable, some of our things are mutable, like lists, strings, and tuples, and so on. So in whatever I have taken the names in this, some are mutable, some are non-mutable. What is mutable then? Mutable is nothing but the one which can be replaced, one wherein we can change. So that means we can change the state of an object. We are saying objects are mutable. It means that the state of the object can be changed by making the assignment to the attributes. Say for example, I want to change the size of a rectangle without changing its position. Then it could be done. How it could be done? Then you need to modify its width and height. So that is what we have done here. We have changed your attributes. We have changed the object with the help of the attributes. So the first method is using the attributes. So you can see again a dot operator. What is the attribute? Width. We are changing the attribute width. That is, we are increasing it by 50. Okay. So when I change your width and height, what is happening? First the attributes are getting changed. Then your object is getting changed. So that means your objects could be changed. So this is one method wherein using your attributes. The second method is using your function. So you can see here I have used a function called as grow underscore rectangle. So once we write this function, what it does, it takes a rectangle object and two numbers which are nothing but width and height, which we have mentioned as d width and d height. Okay, so this is d width and d height, and then we add the numbers to the width and height of the rectangle. Inside this function, what we have done, whatever the new arguments we have taken, that are getting added to the width and height of the rectangle, wherein we have defined your rectangle already in the function, which is RECT. Okay. Now, after this, let us say, in order to demonstrate it, what we have taken now, we have taken an example here, that is box.width, box.height, which are nothing but 150, 300. So that means we are passing the arguments. Okay, box is nothing but it is an alias for your rectangle. So that means whenever the function modifies a rectangle, the box also changes. So that's why we are written here box.width. Okay, it is an alias for rectangle. Now, so later what we'll do, once these arguments are passed, that is box, 50 and 100. Box will be mapped to rectangle, 50 is mapped to d width, 100 is mapped to d height, and then we will call our attributes, which is box.width is nothing but what now? Rect.width. Box.height is nothing but what now? Rect.height. Then we'll get the new width and height. Right? So this is other method by using your functions. So that means our objects can be changed by using two methods. One is attributes and another one is functions. Okay. So moving ahead, we usually what would happen with the aliasing is there we face some problems, like we may get some unexpected effects which would cause an error. So therefore it's very difficult to keep track of all the variables that might refer to the given object. So therefore, in order to avoid this, we have one more alternative method called as copying. So this copying is used as an alternative to your aliasing. Okay, so and this copying can be done with the help of the module called as copy. We'll be using an inbuilt module called as copy. So you can see here p1 is equal to point. We have created an object called as point. Then we have called two attributes x and y. Then we are told import copy, and we have used it copy like copy.copy of p1. So what this copy module does is it contains a function called as copy which will duplicate your functions. So here p1 and p2 contain the same data. That is, when I write copy.copy p1, p1 and p2, both of these objects contain the same data. But remember friends, they are not the same point. Like say for example, if I'm trying to draw a line, first I will put one single point, then I will put one more point. They both are almost at the same position, that is 3, 4. That is 3 is x-axis, y is 4x4. That means they are 2 points at the same value, but they are not the same point. Remember this friend. So in order to demonstrate this, we'll try to check the data. So if I print point 1, that is p1, I'm getting 3, 4. If I print point 2, that is p2, then also I am getting 3, 4. But we can check whether p1 and p2 are the same points by using your is operator, which will be returning a boolean value. So if you want to check this, then we'll try p1 is p2, that is operator. So when I get a false, it means that they are not the same thing. Okay, now this is bit convincible that you can say is giving us the correct answer, which is false. But what if I use a double equal to? Say I am trying to use a double equal to. What usually we expect when we use double equal to? That these 2 points are containing the same data. So therefore we expect that the output must be true. But friends, please observe this, the last point. When you use double equal to operator as well, the answer you are getting is false. So what do you infer from these points? These points tells us that this double equal to, it checks the object identity, not the object equivalence. So remember, equivalence is not being checked by your Python. That is, Python doesn't know how to consider equivalence. Therefore, we will try to define all your programmer defined types. Using programmer defined types, we will try to get the equivalence. So remember friends, equivalence is not inbuilt in Python, right? Equivalence could not be determined, but you can determine the identity, right? So therefore you are getting here false for both is as well as equivalence operator. Okay, now we have two important functions. One is copy.copy and another one is deep copy. So this copy.copy, what it does is it tries to duplicate a rectangle, and you'll find that it copies the rectangle object but not the embedded point. Try to understand here friends, it only copies the object but not the points which are there inside that object. So if you want to understand it further, you can see the below example wherein we have taken box2 is equal to copy.copy box. Then if I try to, the object has been copied. When I use this copy, the object of box has been copied into box2. But when I check is box2 equal to box, then it will give you false. That is, it has been not copied. But when I check box2.corner is box.corner, yes, that means this operation is called a shallow copy. It copies the object and any references it contains, but not the object which is embedded. Remember, there is a small difference. You have already seen an embedded object. So this shallow copy, what it does, it copies the object and the references. That's all, but not the embedded object. That is, the object within an object cannot be copied. So in order to make it further easy, or in order to further advance it, we have a deep copy, a modified method or a modified function called as deep copy. This not only copies the object, but also the object it refers to. That is, embedded object can also be copied, and the objects they refer to, and so on. So therefore, this deep copy operation is very much essential or very much good. So you can see here box3 is equal to copy dot deep copy of box. Then what will happen? It will copy the box within a box. But why we are getting here false? We are getting here false because the deep copy, sorry, box3 is not the same object which is within a object of box. That is, box 3 and box are two different objects. That's why you are getting here false. Okay, so this is all about your chapter 15, module number 4. Thank you for watching. Thank you.